Okay, here we have a slightly awkward denominator rationalisation question. Start by copying out the fraction, and then we need to multiply it by something. But just before we do that, I just want to point something out. This is not the square root of 4 multiplied by b. It is square root of all of 4b. I've seen a lot of candidates writing that in their working, and then later simplifying that to 2b, which is wrong. It would be 2 root b. So just be very careful. Now that symbol there is a multiplication, not a cross. We're going to multiply by a plus square root of 4b over a plus square root of 4b, and I've got that from here. We look at the denominator, ignore the numerator. The fact that these are equal to the numerator is a complete coincidence. We need to look at the denominator only and simply change the sign here. That's a minus, so here it's a plus, and here it's a plus. If that was a plus, then this would be a minus, and this would be a minus. That's all you need to change. And then you actually just need to carry out that multiplication. So I'm first going to write it as a single fraction. So numerator times numerator, denominator times denominator. Our numerator then multiplies out using the normal double bracket expansion method to that, and check it yourself. And the denominator, using the same method, looks very similar with different signs, comes out to be this. Now the thing is, if you've done lots of these, you'll know what to expect. And it just makes it so much easier if you're well rehearsed, because the next thing to do is to cross out these two terms. But the whole point of doing this was so that that would happen. The reason we do this process where we take this sign, we change it to the opposite sign, and then we times it by that over that, is because it will cause, in a few moments' time, these two terms here to cancel each other out, leaving only rational or non-surdy bits in the denominator. So since we knew that these two were going to cancel out anyway, what was the point in actually writing them there in the first place? Why couldn't we simply just write a squared minus 4b there? Well, we can, and you should. Okay, all that remains then, it seems, is just to combine these. We've got these two terms are the same. So you've got one lot of a root 4b plus another lot of a root 4b. Well, that's two lots of a root 4b. Just put the denominator in. It feels like that should be the final answer now. It doesn't simplify. What a lot of candidates did was this deeply irritating thing where they cross out and cancel out those two a squared. Clearly you can't do that. A squared is not a factor of the numerator and of the denominator. It's just one of the terms then. Just because it's the same, you can't cancel it out. Equally, based on that logic, we should be able to cancel out the 4b's here. But that isn't logic at all, so don't do it. You can't cancel those out. So I'm just going to restore that how it was. So what can we do here? And the answer is not really very much at all. The only thing we can do is to slightly simplify this term here. And to do that, let's just do it separately, and then we'll feed it into the main stream of working. You'll notice that we can actually write root 4b as square root of 4 times the square root of b, which I've done over here. Of course, the square root of 4 is 2, so that's 2a, 2 root b. And then the two 2's can combine to give you 4, so it's 4a root b. And that is slightly simpler than the existing highlighted term there. So all that remains is just to replace that with what we've found, and that's as simple as our answer can go.